So over here, you see this VPC. So VPC is actually acting as a shield. You see over here, it is acting as a shield. You see this outer circle, it is acting as a shield, outer rectangle box. And inside it, we have EC2s. See, we have EC2s. We are keeping EC2s in a proper isolation with the help of VPC. Okay. Now, so we know that we need servers. Servers are addressed by EC2. So we have EC2s here. You see this EC2, 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 EC2. So we have servers over here. Second, we need security. From where will we get the security? We will get the security with the help of VPC. Now VPC acts as the outer shield. Okay, it acts as an outer layer. But what we have to do to protect inside? To protect inside, we create subnets. Subnet acts as an inner shield. Okay, subnet acts as an inner shield. You see this? Every EC2 is actually inside this subnet. So all these three EC2s are in one subnet, and these three EC2s are in one subnet. So we are basically protecting these EC2 again by creating another layer inside VPC, and that is subnet. Okay, I hope it is easy to understand. So we have our outer shield that is acting as that is known as VPC, and we have inner shield which are known as subnet, and that we are basically making it subnet so that it is acting as an inner shield, so that if anyone gets into VPC, that's okay, but he might not be able to get into subnet. Okay, so that's why we create this sub networks. So how we divide the VPC? We divide the VPC with the help of sub networks. Subnet stands for sub network. Okay, now, so we understand EC2, we understand VPC, and we understand these security with the help of VPC and subnets. Now, we have three layers: front end, as you guys said, front end, back end, and database. If you look at the architecture, our front end is kept on these two servers. Our back end is kept on these two servers. And our database is kept on these two servers. Can you see? I think you guys are getting closer to this diagram now. It is making more sense. When you might have seen it very first time, it might have frightened you. But right now you have started understanding this diagram, that the outer box is VPC, which is acting as outer shield. Inner shield is acting as a subnet. And now we have in the inner shield, we have kept EC2s. Okay. Now, when we look at these EC2s, right? So these two EC2 we keep for front end. This layer of EC2 we keep it for backend, and last layer we keep it for database. Now there is a question which I'm expecting from all of you. Probably you guys have it in your head right now. Why do we have two servers for each layer? Front end has two servers, right? 1, 2. Backend has two servers, 1, 2. And database has two servers, 1, 2. You know what? IT is vulnerable if there is no backup. There should be always plan A and plan B. There should be a backup. Of everything, you need a backup. So what you do, you deploy these EC2 instances in availability zone, maybe A. And you do, what is availability zone, guys? You might have studied. Availability zone is data center. So this data center is, maybe let's imagine this is in North Virginia, okay, somewhere in North Virginia, and this is again in North Virginia, but another part of North Virginia. North Virginia is a bigger one, right? Maybe these two data centers are 100 kilometers away. Okay, so what are we doing over here? That we are keeping the front end one server for backend, one server for database into one data center, and we are keeping another layer of servers into another data center, which might be 100 kilometers away or 300 kilometers away. but we are keeping it a backup. Why? Because, in case of any natural calamity, there is a war, or there's a natural calamity like earthquake, storm, hurricane, a lot of disaster can occur, right? What if the entire data center goes down? It goes down, everything has gone down. Let's imagine Ukraine right now. Let's imagine this one is in Ukraine and Russia has attacked Ukraine. So complete Ukraine, and there is no data center which will be working right now because that is the war zone. So this data center has gone. Now, if my application is running, will I be able to do the business? If I am dependent on one data center only, my business will be affected. That is why we always keep a backup plan. We always keep our servers into at least two locations, because if one location is affected, then we have other location up and running and taking care of all the traffic coming in. Okay, so that's why this is data center 1 and this is data center 2. And that's why you see for front end, there are two servers, for back end, there are two servers, for database, we have two servers. Now, see what happens that if I'm not sure if you guys know this, when you have two servers, right? When you send a request, when you open a Thinkcloudly, Thinkcloudly is running on these two servers. Okay, Thinkcloudly is running on these two servers. It will be too confusing that where the request will go, either to this server or to this server. It's not possible. For that reason, what we do, we place application load balancer in between. What it does, it randomly distributes the traffic. Let's say if Wemo is sending the request, his request is coming in and going here. If I am sending the request, my request is going here. Okay, so this load balancer is balancing the load, because every day it might be receiving 1 million requests. You cannot overload this with 1 million and this server is sitting idle with 0 requests. No, this is very unfair. So what this load balancer does, it basically distribute maybe 500,000 requests over here and 500,000 requests over here. So it basically distributes the traffic evenly with both the EC2 instances. So that is the work for load balancer. Now, there is another load balancer you will find over here. Now you can ask me that, Naman, why are we keeping two load balancer? And my answer will be that, again, if front end is trying to contact backend, it will send all the requests to same backend. How does it know that half of the requests can go here? So what will happen? We will link these two front end servers with application load balancer again. And this load balancer, what it will do, it will divide the request into these two backend servers, so that 50% of the load this will take and 50% of the load this will take. That's why when the request is actually coming and hitting it, we have the load balancer in place so that it can distribute the traffic. Again, when front end wants to talk to backend, it is again hitting the application load balancer and it is going here and here. So what is happening? At every stage, you are balancing the load. Now you can ask me that, Naman, why don't we have the load balancer over here? Because at the third layer as well, we might need the load balancer. So why don't we have? Because backend talks to database directly. Okay, so backend talks to database directly. We don't send the request to another database. We send the request directly to database. Okay, so now you understand what this VPC does. It creates the outer shield. You understand that what this subnets does. They basically create an inner shield. You understand that what these servers are doing. So this is keeping the front end code. This is keeping the backend code, and this is keeping the data. Okay, you understand these layers. You also understand what this application load balancer is doing. Application, whatever request which is coming inside this application, this is getting distributed into these two servers. After that, from here, the request will go to another application load balancer, so that furthermore it can be distributed. Okay, and after that, it will basically talk to database directly in the same zone. Now over here, we have this arrow. Why do we have this error? Because if let's say a data is printed over here, we maintain the same copy of data over here. So we do the regular backup. This is called as sync. We keep both the databases into sync so that both databases will have the same data. We want to keep the same data. Okay, because user can come from here or user can come from here. User should see same data. It should never happen that on Zelle, when you're checking your balance, you are seeing the different balance. It never happens. So your data should be here, same data over here, and same data you have to keep here. What will happen? This will make sure that your databases are in sync and balances whatever data you have that matches. Okay. Now there is something we have again, the auto scaling group over here. If you see these two components, we have auto scaling group. Now what happens that, as I told you, that these are the electronic machines and anything can happen to anything anytime. I mean, anything can go wrong with the server. Let's say this server dies. So it's impossible for me to identify that server has gone down and I have to go and create a new server. It is very impossible for me because in a runtime, in a real environment, it is very difficult for me to do the configuration again and bring it up. Auto scaling group will monitor these two servers. This particular auto scaling group, which is front-end auto scaling group, will keep a check on these two servers. If any one of the server goes down, it will immediately create a new one. So auto scaling group is important. Over here as well, when you have EC2, we have a backend auto scaling group. If this server goes down, auto scaling group will identify, oh, this server has gone down. It will again create another one. And this auto scaling group will get another one. So this is called as multi-tier architecture. Why? Because you have, what are the components you have? You have EC2, where you're keeping your front end, back end, and database. Second, you have the load balancer. Why do you have load balancer? Because multiple servers are involved at multiple layer. So over here at this layer, 2 servers are involved. At this layer, 2 servers are involved. You want a proper load balancing. Okay, whatever request is being transferred, you want proper load balancing. That's why we have a load balancer. Third, we have an auto scaling group. Why do we have auto scaling group? Because manually it is impossible for us to monitor all the servers 24/7. So what auto scaling group will do? Auto scaling group will identify if anything goes wrong, it will immediately replace it with the new server. So that's why we need auto scaling group, and auto scaling group is the reason for auto healing. When I was mentioning about auto healing, it was about auto scaling group. After that, we have the VPC, which is acting as the outer shield. And then we have the inner shield, that is the subnets. Okay. Then after that, we discussed that we have 2 data center, 1 data center and another data center. Why? Because if anything happens to this data center, we still have our application turned on this data center. So for backup, we keep we deploy the multi-tier architecture on 2 different data centers so that if something goes wrong, we have the backup of it. So that's why we have 2 availability zones deployment. And this deployment is also known as multi-AZ deployment. Why? Because there are more than 1 availability zone is involved. And what is availability zone? Availability zone is nothing but the data center. So that's why, because 2 availability zones are involved, that is why we call it as multi-AZ deployment. Okay. After that, so we understand the basic nuts and bolts. Let's look at some of the more security we see in this diagram. If you see, this is public subnet, this is public subnet, and this is private subnet, and this is private subnet. If you understand, this private subnet is actually from here to here. I mean, we are keeping these 3 servers into private and these 3 servers into private. And these are public. Public means anyone can access it. From internet, anyone can access it. Private means from internet, no one can access it. This is the extra security we are creating with the help of private subnet. From internet, directly, it is not accessible. How will we access it? From internet, first we will go here. And if this allows, we go into this. That's why we need Bastion host and Net Gateway. Net Gateway and Bastion host, what they do, they basically allow the traffic to go inside private subnet. Okay. So this is very important. This public subnet we keep over here to ensure whatever traffic is coming inside, it passes through this. Otherwise, we cannot expose the whole application to entire world. Anyone can hack it. Anyone can hack it. That's why we keep our important layers, front end, back end, and database into private subnet, which makes it private so that no one can access it from internet. And why do we need this particular layer? We need this particular layer because the traffic which is coming from outside will be validated and then it will be allowed inside in the private subnet. So this is the extra hop we add just to make sure that our traffic is getting passed on and filtered over here itself. So that is why we create another hop over here. This is the part of the security. And if you guys, I hope you guys are going to learn it in future. Okay. So this is what I wanted to discuss. I hope you understand all the nuts and bolts of this particular diagram. If you guys have covered VPC, this architecture will make more sense. If you are going to, discuss with your instructor about VPC, then after your VPC concept, look at this diagram again. I am sure that this diagram will make more sense to you. And I tried my best to make sure that you understand each and every nut and bolt. We will be sharing the recorded session with you. Watch it again, come back with questions. We will appreciate all your questions you're going to ask.
Thank you for watching. Switch from non-IT to IT today. Explore www.thinkcloudly.com.